This is a different type of calorimetry problem in that we're trying to determine the heat associated with a chemical reaction. So here's our chemical reaction. It's an acid-base neutralization, and this is an exothermic reaction. It's quite exothermic, actually. So we have 50 milliliters of a base added to 25 milliliters of an acid. They both start at the same temperature, and heat is released in the course of the reaction. The temperature of all of the solution, the 50 plus the 25, 75 milliliters of solution, increases by 2.21 degrees C. So we're going to use the first law to calculate the heat involved, the heat that's evolved by these reacting chemicals. All right, so here's the first law. Heat gained plus heat lost equals 0. The water is gaining heat, it's gaining in temperature, and the chemicals are releasing heat. The chemical reaction, as a result of the chemical reaction, heat is being released, and it's this heat that's lost that's entering into the water. Now, to do this problem, we are going to have to make one assumption, and that is that the solution is dilute enough so that 75 milliliters is still equal to 75 grams, meaning that the solution has a density the same as water, which is a pretty safe assumption. But we do have to make that so that we know now that we have 75 milliliters of solution. It's going to be equivalent to 75 grams. Alright, so we've applied our equation and multiplied out the mass times the specific heat times the delta T. So we have the heat gained by the water. So the heat gained by the water plus the heat lost has to equal 0, which means that the heat lost is a negative 693.5 joules. Alright, so we have the amount of heat that's released in the reaction, and we want to convert that from simply joules to units of kilojoules per mole of water that's produced. We have a volume and a molarity of both the base and of the acid, so it is a type of limiting reagent problem, and we can calculate how much product water is actually produced and churn out our final answer. Alright, so we calculate the moles of sodium hydroxide we have initially and the moles of HCl we have, and we have an equal number of moles. This problem was set up to be a bit easier from this point on. So everything here is a 1 to 1 to 1 mole ratio. So we know that the amount of water that's produced is the number of moles of sodium hydroxide and hydrogen chloride. It's all 0.0125 moles. So we can do our final calculation. Here we are. We've completed our final calculation. We have the heat that was lost from the preceding calculation converted to kilojoules and then kilojoules per mole, crunched out and rounded to 3 sig figs. Note that this negative sign is consistent with an exothermic reaction.